Pascal.
Hello, hello.
Hey, Koi.
Hello.
What's up?
Everything is all right. Okay. Can I ask the two of you to add your names? I know it's like 10 minutes before the meeting is always like a lot of merge conflicts. Maybe there are pull requests that I have not.
I have my pull request open, but I don't have merge, right? So
Yeah, okay, that's why. It was like, that's probably why. Okay, let me merge. Um, oh, yeah. Hey, Sabrina.
Hey, how's it going?
Uh,
Hi.
oh, so I'm gonna close Sabrina's pull request. Okay, so Hugh will be a couple minutes late. Yeah, I feel like we can get started. Hi everyone. Welcome to the July AI working group. Before we get started, I just want to make sure everyone should sign the membership agreement, participation contribution guidelines, and the code of conducts. I will be introducing the attendees today. So I'll start, and then let's use the orders in the attendee list. So my name is Kuwei. I'm from Meta, and I'm joining from Menlo Park, California. And then Anastasia is not coming, so I need to delete her name.
Cool. I think I'm next. I'm Mike Lorbello. I'm at Airbnb and I'm joining from San Diego, California.
And Sabrina.
Hey everyone, I'm Sabrina Wasserman. I'm also from Meta and I'm joining from New York City.
Hello, I'm Mark from Yelp from Austin, Texas.
Jeff.
folks, Jeff Royama here from Apollo, joining you from Monroe, Connecticut in the US.
Huey is gonna be a couple minutes late, so we're gonna skip. And then I think Pascal. Yeah.
Pascal, joining from Zurich.
All right. So yeah, because Hugh is gonna be late, let's swap the order of things. Sabrina, do you wanna start with talking about the AdMock implementation inside Meta? And then yeah.
Yeah, I'm happy to chat a little bit about it. I know Michael's also worked on this space as well. We've been looking into AppMock specifically as a use case for AI generated testing, specifically where we get a bug report where the specific GraphQL data is either difficult to replicate or it's difficult to create the right circumstances to have that bug show up. And so we have mock basically working as we can give the agent the task. It can basically convert that into what GraphQL fields it should attempt to mock and then try to create that state. It's pretty useful for cases like unexpected nulls or empties in particular. But I should add, we're very much in the early stages of this. Like we've only very much just started to run the evals on the usefulness of AppMock comparative to like injecting data on the server, say, as of like this week at Meta. But that's most of what we've been exploring as of now. Yeah.
Awesome.
What's your AI-driven workflow? You're working for the web team, is this correct? So Relay and web?
I essentially work on mobile relay, so I work on an equivalent.
Right.
Yeah.
Okay. Do you use internally? Do you use in mobile apps? Do you use the what's it called? React the React thingy which is compiled, or is it native apps that you write?
Oh, we write native. Yeah.
Native. Okay. Interesting, because that's a how do
I
you
think
use
you're talking about React Native, right? The
Yeah, I
React
was talking, I
component
was
of
thinking
native,
about
yeah.
this. So
Yeah.
are you using React Native? Okay.
No.
Okay, native app.
Yeah, so we essentially have our own like GraphQL compile step that like it's like a CLI script right now that you can write your GraphQL queries. It'll generate type safe models in either Kotlin or Objective-C, and then product developers basically use that with native frameworks we have. So no
Okay.
React.
How is your flow with mock at the moment? Because I think that's going to be very interesting to compare with web.
Yeah, so it's very much a prototype right now. It's not great. So one of the things right now we have with mock is that we don't want it to be committed in any source code, in particular because it is set up such that it will always be compiled out of production builds, but we don't want to set up a case where like someone accidentally lands a mock, internally developers get like, mocked data, and then externally prod users get something else because the mock pieces are compiled out. Right now the workflow is painful. So what we do is for your particular app in your build config, you have to provide basically like a JSON file that the mock can point to. And then what we've done something a little bit different from the open source implementation, but that JSON file basically contains any of the mocked either scalars or objects. And it has like a unique ID that the @mock directive takes in. So essentially @mock has an ID that could be like my mocked data. In the JSON file, it'll have my mock data. On app start, we read the path of that JSON file, and then that's how we end up mocking it. And we do it as like a post parser step. So it's somewhat painful just because you do have to link up that JSON file whenever you basically want to use that mock. And because we don't want that compiled in as of now, that's not like a permanent piece. Again, it's very much in its prototype stage, but that as is pretty gross. Like we have to start with instructing the agent to just set up the mocking in our build step. It is like a 2-line change, but ideally it would be a little bit simpler. For context, the reason we haven't done it something slightly more intelligent, like do it with debug builds, is because ideally long term this would be like co-located JSON files with the GraphQL, and to do that with the build step and like have it picked up only for prod builds is just more complicated while we're just proving out the use case for like agentic testing. So it's not great is the TLDR.
Do you collocate the fragments with the usage, or is this like the common architecture, the common backend architecture that front-end mobile developers also do on the mobile apps?
So the short version is we want to the collocation for fragments and collocation of mock are a little different. And it also varies a lot depending on what app we're talking about. So for example, apps that are new with GraphQL, we've prioritized collocation for fragment models and by extension, mock a lot heavier than, say, Facebook, for example, which just, as you can imagine, is like a lot of archaic GraphQL code, and so it's a lot more difficult to enforce that. What we want the mock design to be, and the initial thing I proposed, at least for our implementation, would be where you actually write the .GraphQL file for your fragment model is also where the mock should live. And in fact, like that doesn't mean there's just one mock JSON file. It means there's n mock JSON files that exist for each either any of the mock data that you're mocking within a fragment, whether it's mocking the entire fragment or it's just mocking like the fields. That was our original design proposal, was it should just be in like a single JSON, or pardon me, multiple JSON files that are co-located. That way it's very easy for the agent to look in that directory, like check the field specifically on that fragment. It also means that your data changes are co-located with your fragments, which by extension means that like you're co-locating it correctly for the right views. So it's like fragment model co-location kind of goes hand in hand with mocks, but that's not as is in our prototype right now. It's definitely something we want to do. It's just we haven't implemented it yet.
Yeah, that's interesting because sorry, Mark, go ahead.
Yeah. Just to kind of pick up quickly on the thread about the location of the mock files and the co-location. So as stated in the RFC right now, it's in like a Dunder mocks directory or something like that, sort of as a sibling of the .GraphQL file. It does say that you should put everything in like one giant, like huge, big JSON file. And I think like I have a note to do somewhere is to be like, oh, like maybe you might want to shard that across like multiple files because that file might get too big.
Yeah.
So yeah, I think that's like definitely an obvious improvement we could do here. What I think we found when writing this document is that the complexity of actually merging in real data from the server and mock data is in itself significantly complicated and yucky enough that like that alone justifies the existence of this RFC, and it's been sort of poured over by the greatest minds in our industry at this point. Benji's had a lot of feedback on it as well. So I think we're sort of as reasonably confident as we can be. I think there's still a couple to do we still need to do, but I think that alone provides value. And then also I'm still kind of hoping that the client middlewares for each graphical client can use that spec, and so you don't have to implement that each time as a user. That can just kind of ship with the clients maybe, or as like an optional plugin. The bit that is still very much up in the air, and a bit that no one's sort of quite happy about and that no one's sort of quite agreed on, and this is the same with folks from another company whose name I'm forgetting right now, is the experience of actually authoring those mocks and how that gets into the system and the user interface to it, or I guess maybe the agent interface to it. That bit seems like the bit that's going to change the most company to company, depending on use case. It's the bit that's the most sort of, we know how to do that, it's a bit easier, we can kind of play around with that a lot more. And I'm hoping that that can still be built on top of the shared spec. The spec does have opinions about how you do that with like the JSON file and the naming of it. And then it sort of like tails off with like, we recommend that you have a skill to do this. But we kind of sort of gave up steam there. And I think one of the action items from the last meeting we had was maybe we want to provide like a companion piece that goes along with this work and sort of buttons that up and makes it a bit more out of the box, if that is indeed possible, because again, everyone's kind of use cases are different. I know Michael wrote a ton about that, and I know the person, again, whose name I'm forgetting, I'm so sorry if you're watching the recording, who was also working on like a different mock CLI. I think that's basically the crux of their issue with this as well, is that it's just about making a sort of nicer interface to this. So if it is possible at all to kind of make that better, I'm definitely kind of interested in doing that. But even without that, I am hoping that the sort of like core like merging behavior of how you merge in mocks itself like is still valuable alone regardless. And yeah, those are my two big thoughts.
Yeah, only to add on this, like my main gripe that I had, and I think I've said this in the, or I've mentioned this in the Discord as well, is that ideally when I write UI code, I probably do not want to touch the TypeScript components, the React components with the fragments in it once we are done with the mocking. And I think that's goes a bit into the same direction as you said, Sabrina, with the JSON files. Do you still have annotations inside of the fragments and the queries?
Yes, we do.
Okay. Because that's something I think would be really nice to kind of have somewhere else that you can essentially on a compile step, just like on a production compile step, you remove it. And then it would just be like, hey, this component actually uses a field which doesn't exist. And then it's pretty clear that you do not ship the mock stuff. And at the same time, once the backend's ready and you can remove the mocked code, the mocked GraphQL parts, then you essentially do not need to change anything in the UI components. You can essentially just remove this, I don't know, __ mock folder or whatever, and it will just continue to work. If there is a way, or if someone figures out while working with this, if this is an option, I think that would be really interesting to see, because that would solve, I guess, your problem with the production case and the configuration, and might also solve my problem there with the change in the TSX files. Yeah. I'll leave it there. I have a few other thoughts, but I want to let other people first.
Before I go, Sabrina, did you have any thoughts on that? Thanks.
I was just going to say, we actually do remove the mocks in a basically compile step. So what we do is when we go to create the trusted documents for the query, we strip any client-side only directives, which includes the @mock. So it doesn't end up, say, getting sent to the server or anything like that, and it doesn't end up getting stripped from the query. But it would still create a problem on the client if you tried to ship client-side code using those fields, just because that field basically won't exist.
Yeah, I think conceptually, I'm looking forward to Mark's comment on this. Like conceptually on the query, it's difficult. If it was on the type, you could essentially just remove it, because if it's gone on the type, then it would never compile.
Yeah.
Because you wouldn't have the field. But on the query, you essentially have to remove the query, which would then this should break the typing, and this should then break the build, I guess. It's also possible. But
Michael, relatedly, I'm also curious how you handle checking in mocks and if you allow that in your repository as well, because I think that's part of the issue. Is we sort of don't have this issue because we don't let anyone check in mocks. We have basically lint and validation rules say, and if @mock even exists in any query, like this cannot be checked in. But one reason that sucks is because, as Pascal was saying, if you want to do client-side development that's dependent on this, and then have it be you implement your server fields later, and then you don't have to change anything, that's kind of blocked because we don't let you land anything like @mock. So I'm curious how you guys have approached that.
Yeah, I have two thoughts. To answer your question, we do allow people to check them in, but we don't allow people to check in that directive. So the reason it's different, so I guess we have the same problem you do, where like if you want to develop against it, you basically have to delete the directive and then like check your thing in. But we have two directives at Airbnb. So one is like effectively @mock, which is the runtime thing, and then one is for generating. And so you basically add a directive that says like generate a mock with this, hints or whatever, and we generate a mock, and it keeps it in sync during code gen. And so people use them a ton for unit tests, actually. So it's like unit tests, snapshot tests, end-to-end tests, like that's very common. And so you actually need those to be stable. You need them to be checked in. And so for that reason, we allow people to check in mocks, but we still run into the same issue as you do with like leaving the directive on it for exactly the same reasons. On like a related note, the comment I was going to make earlier was I had pitched this as a thread in Discord to see if there was interest, but related to that first directive around like how we generate mocks and like the interface into doing that. If there's interest in like collaborating on something like that, I think there's potentially an area where we could have basically like a a sister spec that says like, hey, here's how we recommend generating mocks. Here's how we've like structured some stuff. This seems to work pretty well. Same with like validating them. I think you don't want engineers to like add a field and then have to go think about like, oh, do I regenerate this? Like ideally it's just built into the build step. So that's something folks are interested in, kind of adjacent, but we could talk about that too.
I definitely would be interested in that if you end up spinning something up.
Okay.
Yeah.
Yeah,
And
cool.
for what it's worth, we have a similar thing with mocking for unit tests that doesn't use the directive that is exact and that you also can check in. That's exactly that. It's purely the runtime testing portion that we don't have a good story for right now.
I see. How do people specify that today if it's not a directive? What do you use?
It's specifically it's a bit of an older implementation, so it's not great. They basically have like a special JSON that if the name matches a particular regex, then they can read it in a unit test. It's not great, but
see.
it is co-located with their GraphQL files, and that's enough for our like test macros to pick it up.
I see. And is that generated or people just like create it however they create it?
It's manually created, which is why
Got it.
we want to ideally also consolidate at mock to use the same architecture as that, so that we don't have this like, every time you add a field to this particular fragment, then like this unit tests JSON gets out of whack because it's
Got it.
pretty gross.
Yeah.
I mean,
Okay. Yeah, I'd be happy to like spin something up based on what we have and we can collaborate on that. I mean, I think we've generally solved the problem where like we run validation, we ensure the mock, like if you change the query, we update the mock for you. There's a whole like strategy around like prompting the LLM to do the right thing, especially as these mocks get huge. So I'm happy to do that. It might not be for like a month, so I don't know how time sensitive it is, but
That's
I'm
totally
happy to
fine.
help.
Yeah.
Okay.
What's very interesting here is that that solves your other problem too, Sabrina, because you can essentially just say -- no mock, which validates that there is no mock at all. So you don't have to compile, remove them. You can essentially just say that a build fails because you forgot to remove a mock manually. Because if you just remove them, then client breaks eventually.
Yeah.
Yeah, it feels like it should be part of whatever client compiler code gen you use that also essentially generates the mock files or validates the mock files. I think that's a really great idea, Michael.
Yeah, that's kind of like that was the original vision of this, is that this is sufficiently yucky that end users shouldn't have to re-implement this behavior themselves, and this kind of should ship with clients. The reason that I really, really like this being standardized rather than every sort of vendor having their own opinion about how to do mocks is that it allows us to build some really cool server integrations on this. And so, for example, like I'd love it so that when the schema designers end up adding the real field that you have previously been mocking, and that field now exists, boom, now PRs go and land on all of those client repos to just like remove those like mock fields, and now you can start using them for real. Cool stuff like that. So anywho, I think it's pretty clear that a good outcome of this, and feel free to dissent to this and correct me if I'm wrong, but it sounds like it would be interesting to refocus the existing spec and have it sort of more narrowly focus on the mock merge algorithm. And I think also the validation algorithm, since that's going to be sort of like shared to all implementations as well, in terms of like making sure that the mock schema that you have ended up generating is actually valid using the GraphQL.js parse trick that we have in the spec. I think that sort of can also be common there as well. But then we would have one or even multiple, as you say, sister specifications that sort of layer on top of that give you sort of more opinionated defaults around how you use this and what the interface looks like. And maybe you genuinely do want to pick and choose, right? Because we have different requirements. Like you all don't want to check in the mock files. I think we would get benefit out of that, like certain types of builds or whatever. So yeah, more work to do. I'm excited. And yeah, I still have this sort of ulterior motive that once we sort of proved everything's great and it's like good on the road and stuff, then maybe we can sort of convince some of the like vendor folks to adopt some of this as like a just kind of like hand over the the appropriate client middlewares. That'd be cool. Yeah.
I'm gonna do a time check here, and then I think we can summarize the next step. I feel like it's pretty narrowed down to a pretty concrete one, like how to make sure the production code doesn't break when we want to check in mocks. And then I want to move on to the next topic, which is actually related, but I think, Hugh, you have a slightly different angle of mocking data. Yeah.
Yeah. Let me share my screen. I have a very small slide.
Do you have the I was gonna say, if you have the chat feature in Zoom enabled, you can send the slides to.
Yeah, I could. Let me publish it and then send it, but let me open my slide first before sharing.
Okay, yeah, we'll figure out how to send it out later then. But yeah, to start, yeah.
Got it. Okay. So the use case that I'm building for is slightly different than, web development or mobile development. So the use case is, we have an agent dynamically generating queries, using schema exploration and everything, and then execute them. And we want to eval the agent's performance on, generating these queries, or just evaluate the agent's performance in general, which might use GraphQL or MCP tools or something else. The problems that we are seeing is that production data, if we try to eval on production data, is non-deterministic. It changes every day. So the eval might pass today, but it will fail tomorrow when the production data changes. And at the same time, we can't really mutate production, which is a bad thing to do. And if we do mutate it, it's going to pollute, production data, creating a bunch of comments and then creating, new pull requests and things like that when we're evaluating. So there's a strong need to mock production data so that we can do eval. Because we don't have, client code, mobile code, we cannot put add mock with the query itself. We have to use something else to implement or to write the mock data. And what we came up with is kind of a Relay-like store. So if you used Relay before, it's kind of a cache layer between the website and the backend, right? The website have a query, it get data from the Relay store first. If it's available, just use it without fetching the backend. And if it's not available, it's fetching the backend, save it to the store for the next turn, and then display it in the website. So the idea is very similar. So instead of having a website, we have an AI agent. We have a store that's similar to Relay in between. And then we have the backend sitting, on the other side. In eval mode, we don't let the agent reach the backend directly, but we have the agents read the Relay store to serve GraphQL data. And as you know, GraphQL Relay works really well with GraphQL, so it's kind of natively resolved, all the GraphQL queries that we have, as long as we have data in the store. So the job of an eval author is, in addition to writing the prompts, that we need to create the mock data that is, truthful to the current GraphQL schema that we have. And then this is what a store looks like. So on the right is exactly the format of Relay store, which just uses as is. So you have a client root and then some root fields with parameters with references to order. So it's a normalized store. And then when you have the reference, you can read the data of that object, right? And then a query may be something like this. And then when the eval or agent send this query, it will resolve the data from this store and then return directly without hitting production. So this way we can mock anything in production. The agent can also mutate data without actually mutating production. It just update the store. As you know, there's an API in Relay that will allow us to update the store and then return the store data. For very complex use cases where the queries or mutation needs to do some advanced processing, we allows the author to specify custom handlers, which are just Python decorators. When given root fields like current user or close task mutation is hit, these handlers call, and for mutation, the handler will just update the data in the store and then return whatever the query expect. And then the relay store will just resolve itself. If it's return a reference, it will just resolve all the actual data from the store. And then similar for query is simpler, it just return the data. And then something that we notice is this is not very specific to GraphQL. It's applicable to other interfaces that an AI agent may use, such as MCP2 or the Meta CLI. So the relay store, at the end of the day, just a normalized graph, right? It's not, GraphQL specific. It's just a way to store data that can represent any relationship between objects. So what if the agent is not using GraphQL, but it's using MCP2 to update or mutate the data? And that would create a mismatch, because if you go to GraphQL to mutate something and then read it from MCP2, it might create different versions of things and then confuse the agents. So what we came up with is a single relay-like store with multiple interfaces for the agents to interact with that store. So if the agent is using GraphQL to access the data, we intercept that call and then redirect it to reading a store, writing a store. The same thing for MCP2. We have different interfaces to interact with that same store. That way, when the agent is doing something through GraphQL, that is reflected in the store. And next time when the same data is loaded using a different interface, such as MCP2 or Meta CLI, it would just load data from the same store, so the data is consistent. So this idea is not only applicable for GraphQL, it's applicable for any kind of interfaces, because a relay-like store can represent any kind of objects and relationship between the objects. So the key takeaway here is that we can put a data store in between the agents and productions, and then create mock data, put it there, so that agent evaluations do not have to reach productions. And it doesn't, it can do evaluations safely, especially for mutation evaluation. And the same store will work with multiple interfaces, not only GraphQL, but also MCP and any other interfaces that interact with production data. And then creating or mocking a query or a mutation is just a Python decorator. And then we can set up, infrastructure to intercept all the MCP2 calls, all the GraphQL2 calls, and then redirect them to, these specified Python resolvers. So that's why we can, mock data and intercept mutations. Yeah, so that was kind of the idea that we're doing, and we're using it to eval a lot of our agents at Meta. Kuowei.
Yeah, this is actually super cool. By the way, I didn't know you were gonna present this, so I learned a lot of things on the fly. So I guess my initial question came when you mentioned like this is a store that can be generalized, not just GraphQL can consume it. You mentioned like CLIs or MCP tools can also consume it. I want to know like how can we make this possible? Because it seems like for something in order to consume the Relay store, they kind of have to understand the schema information like kind understand, right? Like basically, it's a let's say it's a type user, and then with this like strong ID, like that relay protocol, then I can look at this stored data. So is that still the assumption here? Like that's basically we have to like whatever that MCP tool or like the CLI we have to do. That's a requirement essentially. I wanna
So it's able to mock and intercept MCP tool. So the interception is, at the infrastructure platform, right? When the agent call MCP tool, we can intercept that and call a Python function, which is one of these. So for MCP tool, the decorator will be MCP tool, and then the name of the tool. And then the handler will provide a store, which is access to the entire store with some arguments that's provided to that MCP tool. And then we use a store API. If you're familiar with Relay provide a store to manually load the data, update the data. So that way, as long as we can intercept the call and redirect it to calling this function, we can mock MCP tool or anything else. And for reading, so Relay may have type name and other things. The custom handler is expected to know how to navigate that.
Okay, I see. And then sorry, this is a dumb question, but this function is only used for mock, right? This is not a production resolver that you would decorate.
Exactly. It's only used for mock
yeah,
data, quick and dirty mock that we don't want to reach production for. Pascal?
This is really cool. Because you said that you do not really have clients, or you cannot really annotate the queries on the fly, and that's the reason why you had to go this route. I am 99% sure that the client folks have exactly the same requirements too that you just have. Because if you render data rendering components, mock's great. Like if you have something that needs to be a data surface and you want to render, you want to make the UI pretty, fantastic. If you have mutations and you have connections and pagination and all of these things, a simple JSON file will most likely not do it, because what you actually would want in a prototype is that when I say add user, actually user is added to the user list. So I think this is not only useful for the backend, the backend only, so to say, use case, quote unquote.
The agent use case, right?
Yeah. I think there's more. There's like this is very, very cool, because like I've just see this now when we have two prototyping skills, and essentially what we tell the skill when we do UI is that do not do any graph call at all. We are just ideating now. We do not do any graph call. And then what the next phase is, once we have a UI with all the functionality that we want to use, and we do this with customers as well, and their business teams say that that's actually what they need now. Then from this UI prototype, we then essentially produce a GraphQL. So essentially we say that take the React components and remove all the mock data, the inline data, and replace it with GraphQL fragments. And this then produces a schema diff. And this is essentially what you have to add to the backend. And these sequences of steps lead to that you actually discover the domain and the problem that you have from the other side, instead of doing what we backend developers do the best, We start with the database design and then work from there to the front end. And then we have something which actually no one ever needed. Working from the other side and showing the customer very early how the screen will work and will look like makes the domain design much simpler. But the moment that you do the second step and you have the GraphQL fragments, everything breaks. Because even if you add mocks, you can no longer add a user and it will appear in the list. You would need exactly what you have here. You would have to patch the store on the client that it works, or you would have to patch the store on this proxy thing. So if this is somehow like, if there can be a specification for something like this, that would be wild. Because question, the code that you have here, is this generated code or is this like typed code? Is it possible that we could just with directives essentially say what to update and where in the store to patch this stuff in?
Right now, I don't write code manually anymore. So all of these directives are written by AI. So we just tell them, what kind of mutations we want to mark, what kind of queries we want to mark, and look at the logics of, what the agent is trying to do, and it will mark the data accordingly.
I think Pascal's question, Pascal, let me know. Are you saying can we make it a deterministically generated code? So not agent generated, right?
I don't think that matters actually. I think you actually have a very good point there. It's essentially you do this like on a server, right? And then you have to do a deployment. This is not on the client.
Yeah.
But why not? Like we have Gratz as a JavaScript implementation.
JavaScript, yeah.
Technically, this could just patch the relay network could essentially just patch in whatever's missing and do the store updates.
Yeah.
That's interesting. I think the problem that the client has is that the API specifically for Relay for the store updates is getting better, but it's still not like a simple function chain call, whatever. But like just thinking about it, doing exactly what you've done here on the client would probably be equally interesting.
This might be similar to Relay custom resolver.
Yeah.
Right. You can create resolvers and return anything there.
Yeah. I think I'm not a Relay expert. I think there's a few limitations. I think Relay resolvers at the moment do not support mutations, but I mean, that's limitations that can be solved probably. But yeah, essentially it would just be, even if it's schema stitching, doesn't really matter if it's Relay resolvers or schema stitching or mutations or whatever.
The reason why we do this in Python and on the server side is that our agent is written in Python, and we want to intercept that call and then redirect it to Python functions. But I guess the idea is generic. You can use any language or put it anywhere, client or server, and it's just like a store in the middle to serve data.
So this works. How do you apply this in practice? Like, is there one of these for a team of this middle layer? Is there one per feature branch? One per for all of Meta? Everything is mocked in the end?
Well, consider we have a mono repo. So that you have to I think that is the assumption here, right? There's pretty much no schema federation. It's like one big schema. Just and then Hugh, I'll let you speak to the rest of it. Yeah.
Right now we use it for agent evaluation. So every eval case can have a mock store. It can define its own mock store, or we can reuse the same store for the whole data set. Or we can have a common store for dataset, and each eval case has ability to override and merge the store, the base store, so that I can customize based on what is testing. But this mocking is only like the author is only supposed to write mock data for queries and mutations that's used by that eval case. So, we don't have to mock everything at once, but we can progressively mock data as we need them.
Okay. Okay. So I'm trying to figure out how this does not interfere when someone else works, but I guess I'm sure it's solved. I just don't understand your way of deployment at the moment. But like if someone else works on a feature which also adds a mutation called close task, but
There's also one limitation I want to call out is that this, all this mock data might get stale out of sync as people making changes to the schema, and we don't have a way to, recognize that. The agent, we just call the queries and then read the data and things that are still working. But in production, those fields might have been removed or renamed or something else, and then it will break in production, but it's working in mock data. So that's one of the big limitations.
Yeah. Presumably, you could have like a schema validation, right? Go through the store because and then like check against the current schema.
Yeah, I think so. It's
Yeah.
all
Yeah.
Python code and objects. So I think we can
Yeah.
validators.
Yeah. I want to push on a question. So do we want this to be a spec or do we want this to be a concrete implementation? What would be more beneficial here if we want to open source this?
I don't have experience with this.
Yeah, I guess it's more of a question for Pascal. Yeah.
I don't see like a spec case for this unless like it would be SDL based, so that you say that we create the mutation closed task and this actually sets the field ID state to closed. That said, like we've done or we've tried things like this, and you really push the limits of SDL there. So I'm also a bit with you there, like just writing it as code is probably easier
Yeah.
than trying to specify something in the SDL.
Yeah.
I'm just wondering, like, this is probably for the client devs. I don't know, like, I would assume this is very specific to Relay. If you use the Relay client, then you would want to have it on the Relay side. On the server side, it's also very different. Like there's no specification needed for this. Yeah. It's I try to place it at the moment. I'm not yet sure if this is something which I would like to have on as a development would it as a product development would like to have it on the edge, so on the server side or on the client side. It's very useful, but I'm trying to place this at the moment. Having it on the client side has many benefits because you can, for example, have two different features which run in parallel with completely mock data, and you can have them under different URLs, and then both can like just do whatever they want, and you have the small JavaScript or whatever layer in the network that essentially replaces adds data to methods coming in, going out. But on the client side, it's like it wouldn't need to be on the server side necessarily. Can you, like, Sabrina, in mobile, can you deploy, like, do you have these preview deployments? It's a bit harder than just having a second URL where you can inspect your application in different stage, right?
Sorry, can you repeat that?
Like if you do feature development on a website on a web app, you can essentially say that we have dev.mycompany.com and I can have pr75.dev.mycompany.com, which then I can inspect the feature on the pull request, which has proven to be very useful in agentic development because you can essentially, without looking at the code, quickly check out if things work. Do you have something like this in mobile as well?
We do, but it's not super reliable. Namely, it's pretty slow. So look, you can set a sandbox URL to do exactly that. The problem is that you're basically limiting yourself to like the specific server that your test code is running on, and so it's not the best DevX for GraphQL.
Right, I
We
see.
run into a lot of timeout issues.
I see. Yeah, I'm just wondering, because I see this very useful, having the code which updates the store so that mutations work and everything else works, and it's essentially, as you say, it's just a prompt now to have a mutation. The complexity of where it's stored in the backend and different databases and event sourcing and all of the enterprise stuff that you don't need to care about as a front-end dev. You have other problems. Then you can essentially just hack this in and build your app.
Yeah, one of the things that I want to call out is that this helped us a lot in terms of permission and data access. Sometimes developer don't have access to sensitive data, but they have to work on, that apps or that UI. So having ability to mark the data, know the schema, is very useful that way.
Yeah, this is something that you have to do in the backend. You cannot return the data to the front end and then replace it in the front end. It's not that secure. Okay. Cool.
I think that's everything. Hugh, I feel like we should talk about and figure out how we want to open source this. If you are interested in it, my inclination is probably as a implementation instead of a spec.
Yeah. Let's chat more about this.
All right, thank you so much. I think that's everything for today. Yeah, it's great seeing you all. We'll see you guys next month.
Thanks, everyone.
Thank you.
Bye.